Okay, class. So for right now, these are just resolving components of vectors. So we're trying to find the magnitude of the component of this vector using SOHCAHTOA. Um, so what we do, and let me just get my pen. What we do regarding this is that, remember, we read this specific this W 45 degrees north. So we read it 45 degrees north of west. Okay, so what that means is that if we go, the reference is our west axis. So this is west. It's going 45 degrees north of that reference. Okay, so in this case, this is the angle of reference that we have. So the two components that we're looking at the x component in the west direction and the y component in the north direction. So these two create a it's essentially creates a triangle, right triangle, where we can use SOHCAHTOA, this being our 45-degree angle, and this being 3 newtons of force. So the way you find these two, legs of the triangle is by using SOHCAHTOA. So here we would go, if you recall, SOHCAHTOA. So the sine of an angle is equal to the opposite over the hypotenuse. The cosine of an angle is equal to the adjacent over hypotenuse. And then the tangent of an angle is equal to opposite over adjacent. So now that we have these, we can essentially determine, we have the angle, we know theta, and for each of these we will know theta, and we know the hypotenuse. So all you have to do is essentially set this up using those four references. So these here are your just the SOHCAHTOA, just this how should I say it? The SOHCAHTOA equations. When we are doing the angle, that is a little different. I'm just going to move to the side. Okay, so in this case, here's our triangle that we created. The angle that we know is 45. So the opposite, remember, the opposite is always, so if we have this angle here, I'm going to redraw it. Here's our angle. Here's the theta that we know, the triangle. Here's our angle that we know. Our opposite is this leg. Our hypotenuse is always opposite of the 45-degree angle, and then the adjacent is the leg closest or touching the angle. So in this case, what we can do is we can use the cosine of 45 degrees, because that's our angle, is equal to the adjacent leg, which we don't know, times the hypotenuse, which is 3 newtons. So our adjacent is going to be 3 cosine of 45 degrees. Okay, and that will give us our specific adjacent. Now, the way we find our opposite is using sine. So sine of 45 degrees is equal to opposite over hypotenuse. The hypotenuse is 3. So in this case, our opposite angle is equal to 3 sine 45 degrees. And when you, so I didn't calculate these out, but that's essentially, you would just plug this into your calculator and it will give you an answer. That is all I have for these two. I'm just going to do one problem. If you guys have any questions on the rest, go ahead and email me. I can create a screencast and send you the way of doing these problems. Awesome. Good luck studying for your tests, and let me know if you guys have any questions.